Good morning, everyone.
Louis, give a couple more minutes. Folks are coming in.
Sounds good.
Louis, let's get started.
Okay. Just get things up and running. Need permissions to share my screen.
Please try now, Louis.
Okay, well, welcome back, everyone. I know it's been a little bit more time since we had a last discussion. Hope you enjoyed last week. Took a little break for yourself, and we can get back into this. Okay, let me just pull this up here. All right, so just going to go back up a couple more slides so we can have a quick jot of memory before we jump back to the material. Before we were talking about what are different impacts of models, what was the hype, what we see actually happening in this year versus last year in terms of what are the top trends that are actually being used and being visualized. Then we talked about the different types of Gen AI. Again, there was no prerequisites of 101. So again, we just came here with the basic understanding of what are different types, LLM chats, LLM RAGs, agentic AI, what those different types of means we went over this last class. And what are the different types in terms of different agents? Because we heard agentic. What does it mean? But there's so many different ones. There's solo agents, agent roles, each to hand off, multi-agent. There isn't particularly one. But the one thing is in common is that each one of these are just different tasks that each LLM rules off of. So it's not a special secret. It's pretty much like a chain, which you chain different LLMs to do different actions and sort of that react part, right? So this is part of the agent landscape. So I'll start off here this week. When we're talking about what is Gen AI adoption, right? We talk about how it's important to ensure we move it to our businesses. Things are changing. I just read yesterday that OpenAI has come out and said they're going to be releasing O1, O3 in OpenAI in the next coming weeks, as they're having great results with GPT-5. So what does that mean? If you thought GPT 4.0 was really good, if you think Gemini 2.5 is getting really great at coding and understanding things, GPT-5 is coming and it's supposed to be surpassing all their expectations. So if your company or your business or your department is not using Gen AI to build things or to use it to improve efficiencies, your competitors will, 100%. And it's not that who's using it better, it's how you can best utilize it to um, improve your workspace and get achievements, right? So this is what we want to do is how do we increase adoption, get people up to basic knowledge of what you can do with Gen AI. So this one we talked about, we said that we were looking at the top case. So if you look back at the hype cycle, we see that software automated engineering is one of the top hype cycles. So this is where I've decided to talk a little bit about how we would do Gen AI adoption inside at SDLC, how you build with that Gen AI, integrate new features that leverage Gen AI into existing products, right? So in order for the implementation to happen, you need to have a technical implementation, knowing what kind of tools are you going to be putting in there, and the second part is the broader organizational changes that come to support this. So going back to week one, we told that it's cool that we can implement Copilot, cool that we can implement an AI RAG that everyone can use or use Copilot Web or things like that. But really, what would be the difference change, right? You have to teach people, hey, you can use this to work, and people will have productivity increases for sure. But will it improve the whole team efforts, right? This is the stuff that we talked about the first week. So in order for it to be a good hand-in-hand motion, it's not only technical, but it's broader organizational changes that need to sustain this. Generative AI enables a new level of automation, being cost-effective and delivering superior quality results. In February 2024, Klarna, they introduced an AI chatbot that allowed them to cut the resolution time factor by 5. So they're showing, hey, we introduced the chatbot. We had 50 people doing customer service, answering people's requests. We actually introduced one that was able to answer everyone immediately, 24/7, 24 hours a day, and reduce the cost of all those headcounts by using this chatbot and maintaining the same customer satisfaction levels. It's not about also saving it, but it's also that second part of maintaining those customer levels, right? So this is just an example of how people are using this on a day-by-day basis. In order to start looking into it, of how I can actually do this, analyze what is your current manual processes that you currently have, identify the tasks and problems, and select which tools would be best for this. As you saw before, we looked at this LLM chats. Is it a RAG that we're looking for? Are we doing something agentic? Is it text to text, voice to voice? Is it something that's going to require orchestration? Once you understand the problems and tasks, then you can start solutioning, right? Once you start solutioning, this would be the best for this. Go back and see how we can automate, enhance those process, and become innovative and have those efficient AI solutions. It seems simple, but again, it takes a lot of time to get that buy-in in order for this to happen. So the rate of adoptions and outcomes can be measured, and that's the most important part. I know some companies are willing to experiment. Some won't unless you have some sort of high ROI. Um, Attached to the business cases. Some just want to just put just some like I don't care the cost implement simply because they want to put they're using AI on their investment report, right? So it really comes down to how can you out measure the outcomes of this Gen AI? And part of the whole part of this business thing is I really want to do, and we'll get into it in the second half of today's class, is how can you actually get real cost and measure its being actually effective? So one instance is determine the number of employees utilizing the new AI coding assistant or percentage of users adopting for new AI chatbots when shopping online. I had a discussion with, I think, a VP of a big company just a couple of weeks ago, and they were asking about, yeah, I can introduce Copilot. Yeah, I can do this. Like, we've been introducing like this, but how do we actually measure efficiency? These people are saying they're getting better results. They're determining like how do we actually get it right? And this is where you sit down and plan what are your adoption rate metrics. So if we know the biggest impact of doing coding is the junior coders, if we measure the time to deliver before on a certain project, what's our time to deliver now on the junior level? Do we see a 30-40% gain? And then for those who are senior and above, what do we see in efficiency from them in terms of how they fast their finishing codes using this? Then you have to sort of build out different adoption rates based off possible seniority levels. And then from there, once you see, okay, we see that 30% of juniors are not able to do code faster with AI, but only 5% of senior level software engineers are able to do code faster with Gen AI. So people are like, well, that doesn't seem like a big win. But then you say, okay, if you grab the salaries and grab the average salaries of 30% of the juniors and plus the 5% of the seniors and you mix it together, this is where you can start getting hard ROI numbers and saying, okay, this is the level of adoption, this is the cost savings. Now, does that cost of all those salary savings of being saved of those hours equate to the license cost of paying for something to be automated for them? Once you're able to go in there and actually sit down and think about here's the number, here's the cost, here's how it's being effective. This is where you can really drive adoption and say, hey, listen, in my department, we did this, we did this. We have 30%, 40% savings. This equates to over $20 million a year. If every single department could do this, this is exactly where it is, right? Once you understand and you talk a little bit more from the technical jargon and move towards more the business establishment of numbers and hard ROIs, this is where the adoption will come and push forward. So why is Gen AI adoption in software development so important? It's so again, like I was saying before, you need to start using it as much people who don't want to. There's people who will use it. I'm not sure also if you saw that Cursor, which is an automated AI tool to select VS Code. They came out and they started with over 100 million investments exactly, I think just a couple weeks ago to start building up their business. And within a couple of months, they have now come and shown that they're over 200 million ARR. So they're getting that revenue, they're getting that money in because people are switching over to something called vibe coding, in which engineers and software engineers are leveraging you're just putting your whole code base onto the system using LLMs to go in and read it. So the difference between using a cursor versus using ChatGPT is that ChatGPT only reads text messages. Meanwhile, a cursor actually reads all the different files that you have in your directory as you're building out your project. So again, this is something that we see that it's increasing productivity. People are willing to pay the money for it because they're seeing true value and they're actually getting things out of it. So this is something that I just tell everyone you need to leverage Gen AI if you're going to be implementing something, because not only will it help in terms of velocity, productivity, it'll help to do that. Of course, there's a lot of people you see um, today that are completely against it, saying it's complete garbage, blah blah blah. But this is where the difference between someone who knows what's happening versus not is that you need to sort of guide the LLM to do it, right? As you guys are the subject matter experts in your field, sometimes LLM won't know. Like I said, I think that I consider an LLM like a junior software developer that can help you work a lot faster. But you need to give and you need to be able to communicate properly exactly what you need and not assume that it knows what you're looking for and give it simpler types of instructions as well. So I think there's a question in the chat. I'll just try to answer. There are metrics that the companies can measure and things that the companies can measure. Do you know if Copilot offers out-of-the-box engagement metrics? That's correct. So Copilot does have engagement metrics themselves. They can see how many people are actually adopting and using the tool in an enterprise level, but you need to have those enterprise metrics, but you can definitely pull that information from them? Great question. So my job to help you is to not only be learn Gen AI in business, but again, as Gen AI, you have to be advocates in terms of advocating the role and advocating its efficiency. So usually it takes someone to make that difference, makes that change. So if Gen AI is already happening in your workplace, that's great. But again, goal here is that if there's no one leading the change, then that change might not happen. So that's why it's something I'm just pushing forward that if you don't see any changes, that things are being really stagnant and you're looking to how can you bring it to the next level, take that courage, take that plunge, come to Wednesday's meetings if you're having questions how you can do it. We can have quick discussions, but really these are things that we just want to help you to be prepared for and have the right tools and have those discussions. And again, the point is that you don't have to be technical to drive adoption in Gen AI. You just have to show the right engagements, right? Show the right metrics, show the right numbers for it to happen. So one thing you need to know as you're advocating for this, that there are Gen AI risks. For those who are taking Gen AI 101, it might be a little bit of repeat here, but I just want to make sure that everyone stays at the same level, building everyone up to par. But when you have Gen AI, there are certain risks that could happen. Sometimes when an LLM responds, if it's not inside the training data set that they currently have, they'll try to answer a response. LLMs right now aren't built to saying, I don't know. You would have to train it, you have to prompt it, you have to say, if you really don't know a question, just say, I don't know, and leave it like that. But if you don't give it those direct responses and you ask it a question, LLMs will give something called a hallucination, which will try to guess an answer based because again, LLMs are based off tokens of probability, and it'll try, oh, this is a probable answer, and it try to answer it, and sometimes it's not correct. Or sometimes it can't tell a difference. It could be example of SQL databases. It doesn't know what types. Sometimes it might confuse a certain SQL code with another SQL code DB or something like that, and it'll mess up languages because sometimes it wasn't trained that properly. So again, there are some risks of reliability. So these are some people that may come up and say, well, I don't know, I don't trust AI because they can hallucinate. And that's the biggest one, right? But now there is something called hallucination guards that go against them, and which we could talk about later. But hallucination guards are to really ground the model so it doesn't have that. And you can see that Google has come out with brand new grounding metrics that have come out and are really trying to change this as well. LLM vulnerable to hacking. So how can you really hack an LLM or example jailbreak an LLM that you could say most people don't know this, but there are different ways that you could write. For example, you could say specifically to an LLM, you could have all these safeties. You could say, make sure it doesn't say anything inappropriate, make things like this, blah, 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 blah. But if you were to write in Morse code to an LLM, it could bypass this, or you could switch it to another, like you could switch, you could put commas and spaces and brackets and put it before every single letter. And the LLM will catch it. Oh, this person is doing is adding extra spaces, letters, and from the letters, but it's technically because they're not saying the word bomb, they're saying B dot dot slash B O O dot 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 dot. How can I build up bomb? It's going to tell the response now because you asked it specifically to say don't see anything in the word that says the word bomb, right? So there are ways to hack an LLM on the front end, on which you have to sort of go against this. So how do you change this risk? When you're adopting an LLM and you're actually engaging it, it's going to be something public facing. We would like to do something called red teaming, and red teaming is when you would try and test the LLM based off multiple variable attacks. And this is something that we can talk about later, but there are ways to mitigate those risks against hacking. Biases and safety. Some LLMs do have some biases. So I think I showed an example before was not in this class, but other examples have shown is if you asked what kind of people are nurses, sometimes an LLM might say female are nurses because they have been trained on probably just on those types of biases in data. Some might say now females and males, some of them are not, but I'm saying those biases can come into your into your workplace, right? So I'm just giving you different examples of when you're going for and you're pushing for adoption. These are different types of risks that you might need to have conversations and thinking about of, is this really a risk if we're just doing coding, right? There won't be that much risk in terms of biases in terms of coding, but if you're going to do something public facing and something on your company data, you have to be watching out for this because it could be something your company could be sued for, right? If something LLM does say something that's not appropriate and you haven't shown that you've taken the right risk or guardrails that you can put onto this. And again, a majority of this data has to be met with guardrails any single time that you come out because guardrails will then double check the input and output of your LLM to ensure that you're covered from there. Again, there's data security, making sure that if you have agents, the risk of having LM agents that people don't talk about is that LM agents, you have an orchestrator that tells an LM agent tool to go and extract information. But if you're not hiding that flow, if you're not having some sort of proxy server happening, if you don't have that part like that happening, then there could be a way of looking at your flow like, oh, wait a minute, this LLM agent's actually extracting an API to this Salesforce dashboard. I'm going to copy this API code and see what other informations I can extract, right? So if you're not putting those different guardrails in places, that will happen. So someone has a question about what are guardrails. So there's different types of guardrails out there. OpenAI has their own guardrails. Llama has their own guardrails. And these guardrails are based off multiple things. So safety, violence, harassment, things like that. And what you can look, all you have to do is Google, just put in Llama guardrails. And you can see that these are guardrails that you put in front of when you receive an input from a user, you then put a guardrail that would then verify the information is correct. Because, for example, you could have a guardrail that says anything that's inappropriate or that talks about bombs or anything like that doesn't get to the LLM. Or anything that looks like a jailbreak to an LLM, you stop it from intruding. So it's a step before the input. So if I were to go back to my base LLM query and I have query LLM response, here I would have a section called LLM guardrail, which will then review the response and say, is it good enough? And it's a yes or no response, right? If it's safe, then yes, then pass to the LLM. If it's not safe, reject the response. So you would have an LLM guardrail in place before it gets to your LLM because you don't want it to poison it. So there are libraries to use from LLM providers, correct? There are some libraries you can use. It does take some configurations, but there are some GitHubs. I can post it. I can post a couple examples definitely after class for you guys can have. So someone asked a good question. Some companies have heard people upload a complete code file to LLMs and ask for feedback. I assume it's not safe. What are the risks with this and how you can prevent that from happening? Just blocking access. That's a great question. So I'll go back to my risk adoption. So I think this goes to the copyright part. So when models are trained on large amount of data, I often use copyrighted content. How do we ensure that they're not going to be persecuted for using copyright owners, things like that as well, right? So what happens is you need to have guardrails in place in order for this to happen. So you need to have an SLA with a company, service level agreement. If you're having, example, Microsoft Copilot Web, if you have Microsoft Copilot Web Enterprise Edition, in those SLAs, it says they purposely will not train their LLM on your data. OpenAI has one as well, that if you sign an OpenAI agreement that connects with your data information, it happens like this. Or if you go to Azure or whatever third-party API providers, if they have SLAs in which they promise not to train your data on, and therefore you can prevent all this happening. But now there has been in the news people, I think, people from other companies that have uploaded their current company code on ChatGPT using their personal private account, uploaded code there, and then asked the LLM to edit this. Now, what does this mean? That means they have taken company data from the computer data into a public domain, which is not protected under any SLAs. It's not protected anything. So that means that now that the proprietary code that was being created, OpenAI now has access to this and can be training their data set on this. So, if the next person who wants to create a product was like, I need to create a product like this because those individuals copy their code into a public OpenAI with no contracts, no nothing, no obligations. They're entitled now to use that data. So it's really hard for you to do it from there. So the best way to bypass this is to have those SLAs in place, ensure they're on enterprise editions, and you can only use those LLMs from there. So that's the only thing that to be looking for. And the other way to other prevent it is to actually have your IT team be monitoring what's being copied and pasted into foreign other websites that are outside, right? Typically like how your email, you can't send an email out to certain domain addresses. Your IT team would have to figure out what's being copied and pasted. I had one company that I joined for to help work with them, and they wouldn't let you copy and paste into even a LinkedIn page, for example, right? You couldn't even copy and paste anything to a LinkedIn chat. So there are ways to put guardrails on OpenAI, Gemini, etc., for those who don't want them to use any other LLMs, or you could block things like that. But again, the main point of it is having those SLAs with this enterprising, saying that they're not to be trained on. So are these safe to use once it's inside enterprise? According to them, yes, right? And that's what the company has to work for. The last thing I want to talk about on this page of risk is cost and controls. And this is something sometimes most individuals don't think about. As much as this innovation is new, as much as this innovation is happening, there are chances that your cost and your controls will get out of hand if you don't anticipate the usage. An example of this was a company that implemented like a RAG interface, which they thought this is going to be great, this is going to be awesome. People are going to be using this for the workplace. So everyone was and they put sort of a budget of $10 per head per month for this one department. And they noticed that majority of the people weren't using it that much. They were using $2, $3. But then the next month, they saw their bill skyrocketed 3 or 4 times. And there was this one individual who's constantly using this application, but not only for work, he was using for personal questions, using for this and that. And drove up the cost, and he was using probably $300 or $400 worth of uploading major documents on there. Um, and really drove up the cost that way. And that was something they didn't anticipate, and because they didn't put any cost controls in place. So the most important part of having this implementation with this is to ensure that you have these cost controls in place. So I'll go back down here, and before we get into a little bit more philosophical part is get into more of the Christian rules. Before I go that, there was a question in the chat. If we use RAG plus LLM, does that increase or decrease the cost to the tokens character set to LLM? So going back to this chart here, example, when you ask a question to an LLM, it's only going to answer what's in this LLM response, right? So it's only going to take those tokens that it knows. But once you have relevant context, you're pulling that information plus an LLM to your response. So you're adding tokens, right? Because not only the LLM now has to respond what the LLM responses, it has to grab information from what's in the relevant context and respond with that. So it will increase cost rather than just a basic LLM. And plus, you have to do the prompting on top of it. So that's something you have to think about as well as you go through this. Good questions. Okay, so one of the major parts of businesses is, like I said before, as you're driving adoption, it has to go through change management. There's three crucial roles in order to have proper adoption. This is sort of something that I try to show a little bit more than just basic just, hey, do this, other ones. It's a little bit more of a mindset. Like this is a good book called The Art of Management Fighting, as you can see on the front cover. There's a popular management coach called Vladimir Tarasov, and he talks about there's different ways to do successful change management. Um, so it requires three roles to be played with: enthusiast, a manager, and godfather. So it talks about having these three roles. You'd be able to grab and who's going to be supporting these three roles. If you're able to successfully have one of these three, you'd be able to then be successful in driving any change in your company. So we'll go through and identify a couple of those. So Nagesh, you had another question. How to control these costs? Is this a size of input from RAG? This seems double-edged swords. So that's the whole point of a RAG, is to help decrease the cost. So when you have your RAG, there's many different ways you can do it. You can choose how many chunks are being retrieved. Um, and again, you can choose the types of how big the chunks are. There are many ways to control these costs. But again, we'll get deeper into those in 103, of how to drive and how to decrease or increase the cost of RAGs.
Yeah, I think it's more about what goes into the LLM from the RAG, right? RAG cost is one thing, but you generally get charged based on how many tokens goes to LLM, right? So if you were to control that, one was what my question was, but I'm happy to discuss more on a Wednesday or something like that if that involves.
Yeah. Yeah, for sure. Maybe Wednesday we can break down some costing ways of doing this for sure. Yes, and there's something called pre-cache. So let me just ask, are there any tools to avoid repeated questions to LLMs, answer from cache? Yes, and there's something called semantic caching, which you can enable. Some APIs do enable this automatically, but there's something called semantic caching that you can enable. So when people have repeated questions, you don't have to use the tokens to do that. It will use the caching that's created. Great questions. Okay, so like I said before, there's three crucial roles: enthusiast, manager, godfather. So who's the enthusiast? So this is subject manager, so that's me in the change. So who knows exactly what's happening? That this could be a project manager. This could be someone who's looking into AI, doing AI. Like example, what could be from one from your sides. Um, is someone who's pretty much, I would say, this me that at least has least most knowledge about this, very passionate, and the person has a cold hard approach, right? The most important part in this book, when they talk about who these enthusiasts need to be, um, they also need to be the people who need to call out when something goes wrong or sabotage, right? So let's say management has told you they can only use this, only have certain amount of tools, but when you try to do it, your work is completely limited and you can't do it, right? So this is where you need the enthusiast will be outraged and be talking to the next part, which is the manager. The manager talks about this part is the team, project lead, client, etc. It is the main change in the management event. The manager oils the mechanism. So the point of the manager is not to be the top level, but be able to lead the team and execute this. So as you have enthusiasts working for the manager is the one also advocating for AI as well on part of their team, helping people with hard questions, pointing them to the SME, and helping them bringing the two people together. And the last part of it is that they call the Godfather for help or approval. So the Godfather here is the person who has enough power in an organization to mediate and solve any contradiction in the unit when a change is being implemented. Godfather has enough authority to even enforce a solution or decisions. So this is something that the manager can't do. It has to be someone who's a little bit higher up. And decisions from this Godfather needs to be enough to propel forward. So an example of this Godfather would be a manager needs a project to be going forward. They're not getting approvals. They're pushing through AI. They need to have someone that's considered the Godfather, which is higher up, that believes in the initiatives, that understands what's going on with AI. So then when you're like, hey, I'm getting blocked, I want to do this AI project, this godfather person is able to then be able to communicate and push the decisions forward, something but due to the authority that they have in the current workplace. So with those three levels, you have the enthusiast who are actually working on it and doing it and knows all the AI principles, pushing forward to the manager. Manager is creating these new projects, pushing them forward. Need the help of that last person and that godfather, right? Without each of these three, they can't happen because you can have a godfather that wants AI happen so much, but there isn't someone who is a team lead that has enough passion enough to do it that should be leading the change. Or you could have a team lead, but they don't have enough people under them that know about the experience about that as well, right? So this is why it's important to have all three in that book, and it talks about how each one is super important for one another. So we're gonna go through a couple of objections and concerns in class of how to handle resistance and change in AI adoption. So well, I'll ask this question to the class, and again, these are responses that could happen and have happened to organizations. But let's say you're sitting down there and you're having a conversation with various stakeholders, and you say, "Hey, I want to improve our area with AI. I think AI is going to help us move forward." And then someone comes up and says, "You know what? Garbage in, garbage out." And this is to me the most common saying I've heard everywhere. The concern is the quality of the AI depends on the quality of the results provided. If we give this AI poor input data, it's going to not give us actionable results. Does anyone here in the class would try to find ways how to respond about the quality concerns of how would you respond to that type of question if we were trying to do a successful implementation of Gen AI and someone comes up with this concern?
Maybe a feedback loop.
Yeah, yeah.
I think
Experiment on a smaller scale and validate.
Validation, that's a great one.
in the past, when we have done some hack and then try to present, it's been some concern, but I think the answer for that one would be using RAG. That can bring down a lot of garbage in, I think.
Okay, awesome. Anyone else?
One thought I have is about it's all about process, right? Enabling process to improve the data, building that confidence, also in parallel working on this can give that confidence.
Yeah. So that's exactly what you're saying is one, exactly what people are saying, data management framework, ensure that validation is happening, that's cleaning, we're going to monetize this, and we're going to be grabbing that information. Communication of how the data is being collected, how it's being processed, and the QA tools ensure that we're going to be having high quality inputs, right? Exactly what the team was saying is we're saying, here's a concern, but here's a strategy that we understand are happening, but this is a strategy that we're going to be doing that are going to help improve the LLM process pipeline. So great. All right, next question that they have of concerns. I like LLMs, but you know what? It's a black box. And I don't like having things that are black boxes. It makes me, it doesn't make me understand how they were getting the responses. How would we then approach this type of questions or this concern that they have?
So build some analytics and help them comfortable with like explaining how this works, right? Good documentation, algorithm, what it does, and basically what is there in the black box, right? Educating them, training them.
Great. Anyone else?
So another approach could be like breaking down into like the smaller tasks rather than asking for a full solution. If you give like a smaller tasks, then actually you're reducing the black box to a smaller one.
Awesome.
Also,
I
I
think
go with the training actually. So having some kind of training, rather than then it may not become a black box. If they show how it works, people may not need to know the inner details, but at least high level how AI works with some examples or so, then it makes feel them comfortable.
Yeah.
awesome.
So, and the big part of it is also testing and making sure that the person first is manually involved or there is data driven. So to make sure that, okay, so these are my acceptable responses versus what the, that way the black box is probably still a black box, but you are working with the, the guardrails as well as some parameters which can make it better response.
Yeah, and the thing is like try with smaller examples of a non-critical data and see the results and get an better understanding of the internals. Then try with the bigger examples of critical data.
Yeah. So typically, adoption will not happen if they really don't understand what it is to the level that human can process. If like those key concerns on how it works, a simplified way, if it can present those results, right? It's more like root causing, how it's thinking, right? Like in a human way, if it can give it, then even though it's black box, adoption will be higher.
We can
Awesome.
enable logging, right? We can enable logging to see what LLM is thinking and why it is answering a particular question in a particular way.
Yeah,
That helps us figure out why LLM is thinking that way and then tune our input accordingly.
Yeah. So another thing would be to turn on the chain of thought.
Yep, we can also do, yeah, perfect. Yes, explainable AI, I think Satya as well. And that's exactly what we can do this, right? So exactly what you were saying. I think every guy's reading this before, but documentations, like you were saying before, how can we document everything, right? How can we talk about the steps, break out and chain of thoughts, things like that, right? Satya's like it. But we can do documentations, steps, models, and evaluation, just getting everything already, right? Like we're saying, everyone, this is great responses, interactive tools. How can we maybe even create a dashboard that explores different outputs, inputs, and outputs, and make the decision making more transparent? Traceability. In systems using RAG, you can do traceability by linking AI outputs back to source documents and where the context was gathered. This is a huge one in terms of RAGs. This probably answers this back to Satya's question. How does we do this in coding? In typical RAGs, you can do called tracing. And tracing is where you can see the input, the context that was being extracted, how the LLM used it, and then gave an output response, right? And then you can see if the model is using the wrong chunks from your RAG, then this is where you go back. It's like, oh, it's actually this part. Or if you're actually seeing it's grabbing the right chunks from your RAG, and it's the LLM not understanding it, then you're like, oh, I need to better prompt the LLM, right? And the traceability part is where you can see how the flow of the LLM is thinking. As Satya was talking about, there is something called explainable AI, and there are some packages that are out there. It's a technique that models the outputs for more understanding, right? So there are something called SHAPE, shapely additive explanations. And there are values that talk about how each contribution to each feature affects the model's prediction. And now, for those who haven't taken Gemini 101, and you can change a model's output by changing things like temperature. You can change different things as different, there's like a different knobs in the kitchen. You can sort of adjust to get different types of responses. When you do an explainable AI, is when you have these responses, it will show you what each of these knobs values are and how they help contribute to each feature. So if the top P responses, the top probable responses are because you chose the top 20 responses rather than top 10, this is why it chose a certain response. So there are many different ways that you can show of how you can adjust your LLM to be more restrict, more lenient, more creative versus having zero temperature, which is zero creativity responses. So this is different ways you can help when you have these conversations, be able to provide strategies for them.
Hey, Luis, one quick question.
Yep.
Since you are in both the industry. I mean, you're exposed to both the industry and then this part, right? Have you come across people like where they have generated the code, right? Like for example, 80% of the code is generated by the LLMs and a combination of the LLMs and RAGs, whatever it is, right? When they deploy to production, right? Like if they encounter an issue, right? How easy is it for a person who has it's always easy for a person who has developed or a group of the team who has developed it versus and generated code in like identifying the issues. Have people faced such issues, like where I can't now, pinpoint where the problem is because the whole 80% of the code was generated by the LLMs.
That's a good question. So in order for it to work, and I would say again, the main part of this is your unit tests, right? So in order for code to be running in production, you need to have some good tests. So it doesn't matter if a human wrote it, it doesn't matter if it's vibe coding, or it doesn't matter if it's an AI code. You should have unit tests on your code anytime before it even hits production. So unit tests should be reviewed of, does this function do what it's supposed to be doing? Is this test of this function supposed to be doing what it's doing? And if you have your unit test and it's showing that actually this tool is supposed to call this API, does it do it? Pass or fail? Passed. Okay, so you know that that's not happening. Like this, so to me, it's not about if it's the code or if it's a human doing it. It's actually the process of you doing proper productionalized code, of having proper unit tests done. Now, if you're failing in production and you passed all your unit tests and you passed everything and you're saying, well, I don't understand why there's a bug that's happening. It passed through all the tests. I ran it in the past and it works here, and sometimes it's not happening there. That seems to me it's a little bit more than just a typical bug. There has to be something way off, because if you're having all your tests and it's able to do all the things you're asking for and you have no fails, that means there's something deeper to look into. And that's a good question of, would it be faster for a human to go through it versus an LLM? I think a human can go through it and use LLM to be faster finding the error. Like you can have it thrown into a cursor book and just have it say, what do you see in error? I would say it's still a 50-50, right? I tried using coding sometimes with the cursor. 50% of the time it's really good, 50% it's not. It is a gamble. If I was something going in production, I know my name and my job title and everything's on the line, I would definitely want to go through the code, everything myself. But this is where but definitely I would say the main part of doing anything with coding like that before, I would put an emphasis on unit tests. But not sure if anyone else would have any ideas they would want to share with that.
So I have a related question. Debugging AI generated code, isn't it the same as debugging someone else's code, human written code?
Yes.
It is, but the problem is the amount of code it generates, right? Like sure, it is smart and all of that stuff, but many a times the negation, right? Like example, all include versus all exclude, right? Some people may write the code in a way, hey, the exclusion of these is implicit to the inclusion, right? So those kind of decisions, it's your coding paradigm, the way you code it completely differs from how LLM may code it completely, right? Sure, you would review it and all of that stuff. I'm not sure if everyone will review every line of code that has been coded by an LLM. That is more to see, like I haven't done that yet.
I think that's a good question. That leads to this question that's on the slide. Right. So an AI system can produce erroneous or nonsensical output code, for example. Yeah. So how could we mitigate this? And so here, I know you had your hand up. Maybe.
Hi. One question to you is other than feedback loop, say you give a prompt, either it could be code or anything, it gives you a response. Other than feedback loop, whether you adopt it or not, how do you train the LLM saying that, okay, if there are certain things that the user has adopted or not?
Sorry, I just couldn't hear that last part again.
So I ask for a question or a prompt or a code or something, and LLM returns you the code or whatever response. How do you guarantee that the response it is given is adopted by the user? Like, other than the feedback loop, like there is a plus and I mean up, thumb down. Other than that, I don't see anything that you are going to any UI tools or anything where you can give a feedback loop, right? Saying that, oh, LLM has given you right information or not.
Okay, so in VS Code, from my perspective, is that when I've used GitHub Copilot and I've gone in and say, please change my code to, let's say, no, I would say like, please clean my code or put comments on my code. It goes into my actual code and actually starts writing lines in my code for me. And then when it's done writing, there's something called approve or decline. So if I click approve, that stays in my code. But if I can also refuse it, if I think it's just nonsensical garbage. So I was able to then press X. And this is the metrics that Copilot gathers, is that if ask questions and you're able to adjust in your code, if you click approve or decline, it shows how well the model did in this part versus that part as well. So there's different ways to capture that way.
Thank you.
And that's a good question. And again, these are things that are real life happening. So how do we tackle this? And I think we'll find out some responses today,
And
right?
other thing, we have our own Git, similar to Git Copilot. What they did in our company is they feed all the code that we have at repositories into our private cloud and LLM, and they started creating something similar to Git Copilot. We have a coder plugin which does it. So what they did is they took a good clone of the Git Copilot and they trained our data also, our coding also. They're giving. So one question I have is there are different patterns, right? Each person does coding different styles. So what I realized is GitHub Copilot comes up with one style. So how do you say which is the right style? Is it majority of the people who wrote the code in such a standard, is the standard becomes the standard of LLM?
So that's a good question. Now we're getting to some philosophical questions, right? How do we because again, there's different, it's like saying what's the right way to wear shoes or right way to wear clothes. There's so many creative styles, how to write comments or how to do this. And there's so many people who are like, no, you need to have these type of functions. You need to put a comma over here, or you need to have this. Like there's so many different ways. And that's a good question. I don't know the answer to this one because there isn't a one way to do things. There are many different ways to do it. And if the code works at the end of the day and it's able to be function, it's able to be used and it's readable and it's reusable, that to me is all that matters. It shouldn't matter about, well, if you're not formatting your comments with backslashes and three dots before you respond a comment, like that shouldn't matter, right? Or you need to have three commas before a comment rather than having it in square brackets. To me, it's now you're fighting over small small preferences, right? So there's different ways to code, and I've seen this fight on LinkedIn many times where you're saying, well, here's a loop. Here's what a junior would write it. Here's how a senior manager would write it. And here's how an experienced software engineer would write it. And although it shows like the difference of improving the code and evolving the code, there's still people who write in the comments of actually the software engineer over-engineered it. He would have done this instead. So it just shows to me that there's going to be definitely no way, yeah, Taz versus Spaces. There's going to be no way to really make everyone happy in terms of that, right? So there could be a universal thing, but right now, everything's being trained on what happened on everything that's on the internet, right? So, and what's in textbooks.
So if I understand it, once everyone starts using AI, we will have something, one or two patterns that will be used. Right now, people are doing different patterns, right? There are thousands of design patterns that you can use to write your code. So now when you start adopting to this, you are streamlining to use few patterns that LLM recommends. So it will be generalized everywhere, all over the universe. It will be the similar patterns that will be used. Unlike today, people have different design patterns people adopt to their styles.
An example of this piece here is I teach an analytics class at a college, right? And I teach students of how to use it. And then I know who's using generative AI versus who's not, simply because where they put the import packages. Typically, in coding, everyone puts the import packages at the top, and then you write your code underneath. But I'm getting code where it's saying you have your code, your imports code, and then the bottom, then they import again, and then they have something going on. And then I know that's whoever's coded that code definitely use generative AI to code that, because we all know there's like best practices, right? And you don't throw imports randomly inside the code. So there are things that I still feel like will require a lot of cleanup, and once we get evolved to a higher Gen AI place, it's going to go like that. But I'll take one more question, Sunil.
Yeah, my question is, I mean, it's more of a sharing a thought, right? I mean, today we humans and we are trying to look at this and trying to understand how it's generating and maybe tuning to the factor, right? If you will, in the coming time, it'll be less of our knowledge, right? It's more of we won't even be able to understand. I mean, we won't be able to ask those questions too, because we are far away from, we don't write that code anymore. So it's a system generated more and more. We have not stopped learning how to write code. So that means we got to take it. It becomes more and more black box. So I don't know how that world is going to be, but I can see that is where we are heading.
Yeah, 100%. And I think there's lots of things to go through, and I think it's great discussions. And I definitely like to keep going down to this, but there's a lot more to cover in today's class. But this is great discussions. I'll have to continue through, but yeah, for sure. So quickly, how do we go through this? So again, some questions saying, let's say our AI generated too much code. Okay, well, let's go through some tests. If you were asked it to build a simple Python loop, how much line of code is this LLM going to generate versus like a software engineer, right? So you grab a software engineer, tell them to write that loop, make it write in 10 code. Then you have your Gen AI do it, and you have it write in 20 code. And you're like, why is it writing it so much? So then you go back to your LLM and you train it saying, I want you to use SDLC best practices. I want you to use commenting. I want you to use formatting. I want you to be precise as always. I want you to do, and you start prompting it, and then you try the test again. You see that it drops from 20 to 15. You're like, okay, well, I see you're still doing these types of loops. I want you to act as a software engineer expert who writes code every single day. And as soon as you write that one line of code of role context objective, you see it drop from 15 to 5, right? So as you go through these different strategies, these different testings, and these oversights, you have to have good user training and validation outputs, because it's not only good enough that's taking out code, but can it be run? Can it be ran without errors? Yeah, exactly. And it needs to have those A/B testing happening in order to determine that's what's really the best way. And this is how you sort of face this part as well. Srinath, you had a question?
Louis, it's a bit funny to tell LLM explicitly, think like an expert software engineer. When we are asking it to code, why can't that be a default?
So that's a very good question. So when you go back and see how LLM models are trained, LLMs are trained on everything, on anything. So example, in order for it to be a good coder, it needs to know mathematics, it needs to know statistics, it needs to know different variables, it needs to know blue and red, it needs to be trained on anything. So before it gets to be a good coder, it's trained on billions of data points ahead. So it's not trained specifically just on coding. So when you go to a layer of an LLM, it has that base layer of this is how everything works. Now, the second layer that they do on that is then we grab a bunch of coding exercises, and then they put that on the model itself. And then they say, generate this code, and it'll start generating the code based off everything it's trained. Now, in order to get the best responses, you sort of have to activate the attention layers inside an LLM. So how do you activate an attention layer? Is saying, okay, it knows, example, if you know a software engineer always does best practices, it'll use its knowledge of how does a software engineer work? Software engineer works like this. Software engineer does this. A software engineer does that. And software engineer does this. It will grab everything it knows about what a software engineer does from its base layer, and then goes to the second layer of coding and say, okay, I'll use this code, but wait, a software engineer wouldn't use this code, it would use more of this code, and then grab that code that it has in its training base and then output that way. So what you're really trying to do is with prompting is that you try to grab the attention layers inside an LLM to get that best responses. So unfortunately, right now with LLMs, you still have to prompt it to get the right attention layers to come out. I think My prediction is by next year, there's won't be any need to do roles in context. That's my prediction. I've seen the way the LMs are evolving, but for now, you have to give it the role in context.
It's a very
Hey,
interesting prediction.
one quick thing, right? Like, is it also related to the cost in a way? Like attention layer seeks or uses more, what do you call it, tokens to be able to generate, like better code versus, like if you are not specifying the role, it'll loosely generate.
So the difference between like DeepSeek model versus a typical LLM is that as the typical LLM transformer model, as you ask a question, it uses the whole bottom base layer, right? And then goes and answers the question. A DeepSeek has something called a mixture of experts. And a mixture of expert architecture layer is that these base layers are now separated into blocks and chunks. So one's all about coding, one's all about this, one's all about this. So it's saying, oh, talking about coding, it's not going to activate all that base layer now. It's only going to activate the experts that it knows that are in that side of those chunks. And that's why the cost effectiveness of a mixture of expert is way lower than a typical LLM because you're only activating those base layers that are necessary for that. And that's how that transformers works. Okay, guys, so I'm just going to pass through this because of time. Just want to make sure we're going through a couple of things. And then the last one's ethical concerns. Again, we could talk about there's ways to do bias mitigations, transparency, and ensure that when you train an LLM, you can train it to be very ethical as well and give it unbiased results. Just before we finish up here for this slide here, we have to understand there's different ways to do persuasion when you do GenAI, but I would say use tools that are available for you in the business world. Choose tools like SWOT, and where it can help identify where GenAI could provide value. Like the keep doing, start doing, stop doing are good examples of this. Before is not only getting yourself pushing in, but to get the team's buy-in. And the one thing I just want to make sure put everyone is the day before something is a breakthrough, it's a crazy idea, right? Some people are going to be very resistant to change. A lot of people are very, very wary of it. But again, this is something that we know that will drive efficiency. So again, gradually increasing GenAI usage based on measurable milestones ensures stable delivery and sustainable productivity growth. So in order to push forward with GenAI, again, create small milestones and use that instead rather than just doing a full-blown implementation. Simply because in a full-blown implementation, you don't know what your current cost would be. You don't know how the documentation, if everything's going to be 100% stable. But if you're able to break things into smaller milestones, and this typically on something that you have never done before, let's say you have done already 2-3 AI gone to market strategies in the past and you've gone and delivered products, then I would say it's fine. Go for it. You guys know what you're doing. But this is the first time you're delivering something huge. And it's best to go through small milestones because without small milestones, you don't know what could happen. And instead of fighting one failed code, you could be fighting 5 or 6 failed parts that are part of it. You could have a failed AI tool. Like, wait a minute, why isn't my agent not working anymore? It's hitting a limit, or it's not able to check my images. What's going on? Or my API is down, and you're having to face 3 or 4 different challenges, and they're happening one after another. The point of doing AI adoption is not only to adopt AI and implement it, but also increase the same satisfaction levels. And that's what's truly bring the true value, right? And that's where you need to think about of just trying to implement something full blown without having at least some sort of experience with your tool stack. And that's what's most important. Again, we talked about measuring productivity, so I won't go too much into this. So you can use GenAI for leaders. There's different ways you can go through it. I won't go through too much through sometimes, but there's strategic planning, decision-making, communication, project relationships, time management, etc. Always make sure that you can verify this. So the last 2 parts I'll focus on finishing up week 2 was where's GenAI making an impact, right? So what I've seen most is what is something that's low risk and that could be high and has high push forward. I notice again a lot of business is that they're including Microsoft Copilot into majority of the tools, and I'm sure majority of people have it here. And for those who haven't heard about Microsoft Copilot before or not getting into it, it's Microsoft 365's AI integration tool that they've gone in and offers real-time intelligent assistance. So for example, in Word, it can help you draft documents, summarize, and create content generation. So let's say you have always done a report in the past. You can give a Microsoft Word your previous report and say, I need to create something similar now based off this topic, right? And Microsoft Word the Microsoft Copilot will then draft you a document very similar to the one you've done previously with the new topic you're talking about, or can create summaries. PowerPoints, it can help you create slide designs now. You can upload a template to Microsoft Copilot on your Microsoft PowerPoint side and do this as well. Same thing with Excel. You can highlight a whole chart in Excel and say, listen, I need to do a pivot table. I need to create this formula. Does this, and this. Instead of using macros, which people were very familiar in the past to do and analyze it, you can actually use Microsoft Copilot to automate a couple of things now that you couldn't do in the past. Outlook, Teams, and OneNote. I think for me, I use the one that's mostly is in Teams, is that if I have a conversation with someone, I always have Microsoft Copilot running in the past. If I'm running late to a meeting, I can jump to a meeting and just type in Microsoft Copilot, what did I miss? And it will tell me exactly what's happening as Microsoft Copilot keeps tracks of conversations through even if through voice, and it gives me a quick catch up of what's happening, right? Or I can, at the end of my meeting, I can say summarize or give me what are the key action points, right? Usually in meetings you have to sit down, capture these notes, but they made it a lot more productive, and I found that to be one of the most tools I use from Microsoft Copilot from there. So there are different ways that I've seen that's creating a huge impact just on the individual level right now. So how does Microsoft Copilot actually work? So it's interesting if you get a little bit deeper into the architecture. I know I said we weren't going to get technical, but I just want to nerd out just a little bit of how it actually works. Is it uses a lot of different plugins, right? So it's not just an LLM that's taking information and responding it out. There's different ways. So I put a quick top 4 on the right side of how it goes in and uses it. But when you ask a question, let's say, let's say I can write something in my Microsoft Copilot at work and say, what did my boss ask me to do last Thursday? And he wrote me an email last Thursday asking me to do, but I don't want to go to Microsoft Outlook. I already have my Teams open. I open the Copilot chat. Like, what did he ask me last Thursday? I asked that question. It goes into the Copilot engine. So instead of going directly to an LLM to start answering the question out, it actually pre-processes my input. And it has multiple factors that are happening at the same time. So it will go through its graph. So a Microsoft graph is sort of its knowledge base. This is where your emails, your files, your meetings, your chats, and your calendars and your contacts are being saved, and they're sort of being graphed around you. So let's say there's let's say there's a Microsoft graph for Satya, right? And he has all his emails, his teams, and everything happening, and it's broken down by month, date, year. It's going to go look and say, okay, you said last Thursday, so that was last Thursday, so that was on this date, this date. Let's look up all the emails, the meetings he had, blah, blah, blah. I see an email February the 5th from here. I'll pull that up as a graph. So it's going to keep here in the post-processing. Then the second thing it's going to do is once it grabs it, it pulls it back up and does something called grounding, which it makes sure it's under that when you have your data, it's going to only use this information to respond. So now that it has your data, it's going to go ask the LLM to perform a response on it. So once the LLM is able to read what's happening on your graph, that's how it's able to extract an information and give that information out to you. But if you ask the question and saying, hey, what's the weather going to be like tomorrow? Instead of going to your Microsoft graph, it's going to go to your Bing or your plugins that it has in here and pull information from Bing and then be able to pull information out. Or if you have it on some sort of data platform or power service, it's able to do this as well. So that's very good questions. I know this is something going a little bit more into technical architecture, but graphs are not part of RAGs, and they're not vector store either. Graphs are memory context windows that you would have to create. It's typically like libraries. There's something called LangGraph, where you can create graphs of different types of memories of different contexts. So let's say you have a file where all your information is stored, and you would see that under a branch of the graph called emails, or you can have a branch of your graph that's called files and meetings. So it's not part of a RAG, but it's part of something called a memory, which is called your long context memory, which is your graph, and that's what graphs are. So they're not being stored inside vector stores. They're only accessed it. So they cost a little bit more than a typical vector store RAG, but the graphs are meant for high, consistent, accurate results that way. But yeah, it's very interesting how they sort of go through each of the different areas here. And again, I left this for everyone in the slides. So Microsoft 365 architecture is what they would say, I would say one of the best LangGraphs that's productionalized out there. And you can use something called Copilot Studio, which is one of their new studios as well, where you can create agents. So you can upload, let's say, all your PowerPoints that you used as your team into a file, and you can then say, you can point a Copilot agent to say, use this to answer any questions that any a newcomer might be having in, and you call this the onboarding agent. And then this onboarding agent, every single time you ask a question, will then pull information from these PowerPoints in order to answer questions to your new employees. So does RAG need to be a vector store, or is it a concept? So RAG doesn't need to be inside a vector store, because remember, part of a RAG is you have to just retrieve information, right? So why do we need RAG? So what is it? So I'll just answer a question like this way. What's the point of having a vector store and breaking into chunks and having into a vector store versus just having everything put into files and you can just feed it directly to the LLM? And the biggest response is why we need to do this is because there is a context length issue with LLMs today. The only context length issue that doesn't have one right now, it's still limited, but it's not as limited, is Gemini Pro 2.5 has a 2 million context window, which is equivalent of having 2 Harry Potter books that's able to read simultaneously and respond. But typically, most LLMs today only have 130,000 130,000 token limit that it can read at the same time. So if you have multiple files in your storage and you're telling it to read all of it, it's gonna only read your top 2-3 files and answer based off that, because it can't process everything you have. So this is why a RAG is needed, because it will do is check which of all your documents actually have relevant pieces and only feed the relevant pieces to the LLM to answer, and therefore reduce your token limit cost. But if you have a chance to feed it all your context, then that's where it possibly get the way. But again, remember, if you're treating all your context, then you're definitely increasing cost. Microsoft is definitely eating the cost on doing this, but again, they have the framework, they have their own vector storage, they have their own costing tools. So for them, it probably costs pennies on the dollar to do something as big as this for them, right? In their way. So yes, so again, this goes back to traceability. So again, Satya, like Nageesh, so again, we can look up what traceability is on Wednesday, but that's a way to check goes out of your RAG to LLM size, and that has to be in what's being stored and being sent to your RAG. Okay, I think that is the topics for PIS2. So based off the time right now, I'm not going to do a quiz. I might save that for the beginning of next class. But right now, it's 12:14. We'll probably take a quick 3-minute break, and then we'll start week 3 concepts. Okay, we are back. So lots of questions, lots of great things. Let's see how we do for week 3 work. So it feels crazy. It feels like we've been here for a longer time, but let's see here. Okay. Share my screen. So this week 3, we're going to go through estimating the cost of initiatives. And this is where we want to get deeper into how can we understand how much of this cost like to do, right? And a lot of question on build versus buy, and why would we want to do one versus the other, or how would we use for best LLMs? And the example that I'm going to go through today is actually using LLMs via API versus running it locally in a production grade environment. Now, this is way different from running it on something that is not production grade and something that can be done normally. But the whole point of it is to show you if you were to actually have something that top companies use and run currently, what would the cost difference be? So we are in week 3. We talked about, again, week 1, how to get trends, insights, what's the importance of using Gen AI, how we can lead the AI adoption through different teams, the type of responsibilities that you have. Now we're going to week 3, understanding the total cost of ownership. What does it cost to develop all these things? Probably get through half of it today. We'll have to go through half of it through week 4 as well. So week 3 and week 4, going through half the costing and then designing Gen AI implementations for next Saturday. And then we're talking about how to build bonus classes. And remember, what we want to do is a final presentation, which is a final pitch and strategy. I'll probably put teams into groups of 3 or 4 to do a final pitch and strategy of how would you outline a Gen AI strategy and proposal, and outlining the different concepts that we're going through the class today. And we'll talk about that more about next week, so everyone can have more time to get in line to understand that. But the whole point of it is to really understand of how can you really pitch and create an ROI plan from there. So build versus buy, and why is this important for AI? Some can say, hey, it's easy to build a RAG, it's easy to build this, and it's easy to build that. But when you build it, when you start counting the cost of, do you have the infrastructure support this? Do you have the infrastructure support that? You're having your high-end software engineers develop something for 3, 4, 5 months, but you realize that they never took a course in AI, they don't know what prompting is, and they're trying to do unit tests on LLM outputs, and you know that LLM outputs are variable. You will never get the same response at the same time, and they haven't built out guardrails. But they didn't know that this time, they messed up, so you have to do this again 3, 4 months. Then your project has gone from being green to yellow to red. And again, it goes down to, is it really worth it? Or let's say you have a bunch of data scientists that you just hired on. Let's have a bunch of data scientists work on it, just build it out. Is that really the best decision to do, right? So there isn't right or wrong answer for this. So it just comes to you have to decide what's best in terms of what you have in terms of resources, and what's wrong, and what tech stack you have, right? So if you have a tech stack in your resource right now, let's say you have Azure, you have AWS, you have Databricks, you have a platform that you can experiment on that has Python notebook environments, that have APIs that can serve the models and evaluate, then you're ahead of the game. And then that means you have all the tech ready and set. But if you don't have any of those things and you're trying to just build it out in VS Code and just hopefully you can just launch it from there, note that there has to be some changes for it to happen. And a lot of companies right now are having those decisions. And like I said before, I put in the comments like a deer in headlights on what to do. So how do you decide what to do for your business?
Okay, Luis, so are we really talking about a build versus buy, or are we talking about whether to implement AI strategy or not? Because typically build versus buy is, should I build it or should I just go buy that solution from outside, right?
Correct. So that's what we're talking about right now of should I buy or build my own RAG or should I buy or build my own LM chatbot, right? There are a lot of service providers that provide this service for you. If you want to build a public serving chatbot, you don't need to go and sit and code it. You can go, if you talk to Azure, talk to AWS, like I want to build a chatbot, like, oh, why would you have to build it? Like we have one right here. Just purchase from us, purchase the contracts, and we have all the code AI already clicked in for you, and that's all you have to do, right? So,
Got it. Okay.
yeah.
Lot of times it's also the comparison between the LLM generated recommendation versus the ML homegrown solution, right?
Correct. So there's also those type of questions as well, and there's a lot of things that people are another side topic is that a lot of people believe that AI is very close to ML and we should be using what's happening. But instead of separating them, I think they should go hand in hand. ML solutions are built on statistics and probability of looking at historical data, then using different types of statistical techniques to predict it, right? Using either forecasting, neural networks, and using mathematical statistical concepts to actually output the information. LLM solutions can understand and read context and use historical memory. So it's like a very powerful librarian. A proper librarian can be able to look and look at a question and give you possible good outputs and good ideas because historians are really good at giving good wisdom, right? But when you come to a typical problem that you know that needs some sort of mathematical rigor, it's best to use an ML solution because ML solutions are still the number one cause of finding it. And I think I even posted a couple of months ago, there's 3 or 4 new ML models that have been able to detect cancer in the lung and the heart with a very high probability, very high AUC scores, due to image recognitions using different things like that, right? LLMs can sort of look at an image right now and sort of process it, but they don't have the same rigor that ML models do. So how I would typically would do is I suggest ML models with LLMs working hand in hand together. So not only you're coming strong with a strong historian or a strong person who has knowledge of understanding the concepts, but then have it supplemented with ML. But that's sort of where I would definitely go down that route. Okay, so just jumping back in here, when you're trying to build a big project like that out of, okay, I want to build my own LLM chatbot, do we just hire a bunch of data scientists and that should be enough? This whole point of the whole slide is most enterprises still feel the need to first hire a bunch of data scientists before embarking AI projects. Although enterprises may eventually reach the goal of building a strong core in-house team, sometimes AI initiatives can rely on vendors who don't have the ability to go out and buy more scientists. But even with a strong in-house data science teams, the reason why that most AI initiatives fail is the difficulties of breaking down business problems right into AI building blocks. So again, the reason why is because the majority of data scientists are very data scientists are very technical driven. They know what to build, they know what they want, but then to communicate that to business functions is not their forte, right? Their job is not to look at your technical stack and say, you know what, to make this scalable, you'll need to change your provider from here and you need to redo this part, right? An enterprise needs to understand before even getting into hiring data scientists is one, what is the AI project I'm working on? 2, what is the ROI that I'm going to get out of the end of this? And 3, do I have the tech stack to support this? Do I have API safety? Do I have the SLAs in place? Do I have this? Do I have vector store? Have a place to store the vector store? So that's something that needs to be looked at before bringing in the data scientist. That's a very good question. I think data scientists won't cease to exist simply because ML is going to continue growing. Generative AI is a pocket of ML. and data scientists will always be needed for ML cases, and as ML will continually improve as well. But I think the role of data scientists will be evolving. I think we talked about before, right? To the product engineer, someone that needs to understand product and AI principles in order to be continued. It needs to be an evolution. So the next part of not only looking at what's the ROI, do I have the tech stack, do I have the security in place? You need to do your data audit of your data, right? A good data scientist will be only work with the data that you give it, but you need to have, before giving to the data scientist, this type of evaluation even being done. The types of data, like I want to build, let's say I want to build a new chatbot based off all previous historical conversations I have in the last 3 years. Okay, great. So where's your data? Or our data is stored in this system. Okay, let me extract it. The extracted data is just pure files and XML formatting. You can't tell who is starting, who's not talking. The transcriptions on the chat logs, because sometimes they might be phone, sometimes they might be incoming through WhatsApp, or there are different multiple channels coming in, and there's like, well, this is data that the data scientists need to use. They need to build from here, right? So if you're saying that and you just tell it to go for it, it doesn't matter if you're going to hire Microsoft to do this for you. It doesn't matter you're going to hire AWS. It doesn't matter if you're an in-team. If you don't have proper structured data, then your strategy is going to fail, right? Like we said before, garbage in, garbage out. Without a model being able to rely on external sources that the enterprise might have ready, this could take time to do, and other AI initiatives could happen in the meantime, rather than just having someone clean the data, unstructuring or structuring it to what it needs to be. So in order for this to be really understandable, a deep analysis on the type of data that's going to be used needs to be done. And clearing structured data is the foundation of any successful business strategy execution. So now that you have, let's say you go through all the steps and you have now understood that you have the architecture, you have now the clean data, all this stuff. Now let's assume that you have access to these data scientists, either through internally, vendors, solution architects, etc. You need to have the ability to now perform several rapid experiments. So these are part art and part science. So to do this is not simply just saying, hey, this works for me, this works for not. Like you need to be able to adjust it. How I found what the most successful AI projects I've seen are not the best technical ones. It's the one that are the most creative. So example, one person could say, hey, I have, let's say, a bunch of manuals that are electrician sheets, right? And I need to be able to read them and create a RAG from these electrician sheets and be able to tell me what I need to do. Now, in these manuals are concept pictures of drawings, of diagrams, of how to connect it, that you can't really just RAG. You just can't really just extract an image and expect an LLM be able to understand how that image will look like and work and what's the purpose of it. So as much as you feed it just the text, as much as you put it in there and you try to feed it the RAG, it's not going to give you the best response. And most people who just know a little bit about it will just say, well, I just extracted the text and that's it. Or someone like, well, I'm going to do an image reader and read the image and that should be it. But it should be more than that, right? What people can do is you need people who are more creative. You need individuals who would say, well, I need to think outside the box. What else can I do? What is graphing? Well, maybe what we can do is break out these manuals and do something called a graph exercise and say, okay, those who want to look at certain images and diagrams, we can create a graph branch that says, here's all the images from certain manuals of how to fix things. And we can label these images and say, okay, this image is to happen if a circuit breaker breaks in a large industrial complex, or this image is for a certain type of current that happens, or a certain sort of outages. So this person who is thinking outside the box is thinking of ways to actually successfully launch the product, because they're looking at ways how to solution something more creatively than a person who just simply, well, I'm just going to read the images and then put them in and see how well the models respond that way. So again, you need to create that team that not only can translate and just do a simple RAG, you need someone who actually understands and was able to go step out of the box and do that art and science of playing with different tools and conduct these experiments without putting a lot of money in it. And it's the whole point of POCs, right? Pretty cheap. And you're supposed to make it super fast and cheap and see if it's actually doable. And you're not going to be boiling the ocean at this time, right? If you have 1 or 2 manuals, how fast let's say you have a hackathon, you have 5 teams working on this. From those 5 teams, how many were able to do it within 3 days, right? And in those 3 days, you can see that a certain team has done it better. Why? It's not because the technique has changed or AI has changed or LLMs have changed. It's because someone on the team was able to think more critically or provide different arts or science to a business solution, right? So there is no one way to say, well, AI is all the same. No, it's the people who are actually implementing the AI and how their experiences and what the techniques they know can really outperform other groups because it's more an art and science as you go through this. So now that you sort of created your POC and from that hackathon, you say Group 5 did an awesome job labeling those electronic sheets. When I do a RAG now, I'm able to actually say, hey, I have a problem with my generator. It pulls me the image of how I'm supposed to fix it and tells me what I'm supposed to be doing at the bottom. That's great. So we do a typical proof of concept, right? Duration could be 1 to 2 months. The effort times between 4 weeks. You probably typically need a team of 4, as we talked about before last week, where you have a team of an AI engineer, your data scientist, you have your data engineer, etc. What's the daily rate that they cost, and what's the budget, right? And then you move to MVP stage. You've done that, okay, that's great. MVP. Now let's roll out all the manuals that we have and be able to throw it in there. So instead of now taking your 1 or 2 months, you're building your solution now that could be 4 to 6, right? Well, how much team do you need to do this? Or what's the cost for that? What's the budget cost, etc. Now you're able to go out and have your MVP and actually launch it in production. You start doing testing. You start doing tests on it till you get to your pilot, and then you go to your full rollout, right? So again, this is the different steps. Most of you already know this as you go. A majority of you have worked out on majority of these big projects before, but this is how usually the cost of development comes from. That each step of development has a certain tagline, have a certain cost, and depending on how long you're doing it, how many people are using it for. But as you can see, the cost does add up. So we're looking at something a budget of 30,000 or even 25,000 to do a small POC, which is pretty cheap. Once you've got implementing something for a couple of months, there is an additional cost because that budget is not only the tools you're using, the AI you're using, it's salary cost, right? The salary cost of individuals for that month on top of it. That's sort of building it out. Pilot as well, etc., and full rollout. Someone asked a good question. Since RAG needs our internal / past business knowledge, would it be build rather than buy? I would say the question is depends. How much data is needed? Let's say you have 1 terabyte of data that needs to be used in RAG. If you were to go and do this yourself with 1 terabyte of data, to store 1 terabyte of data chunked, context embedded, to do that, it's going to cost you almost $500,000. I just know that for sure, just to process that data. And that's not even going into grabbing that data set. But there's companies out there that are going to say, oh, you already have it on our, let's say you're using Microsoft, you already have it on our PowerPoint. You don't need to host it or RAG it. We'll do that for you. Or we have it here. You have it, let's say you have it on Box. We have a box for, we have a RAG for Box. And you don't need to go and pay for the vector store. We'll just pull it directly from your files. Then you definitely would go for a buy in that case, simply because it doesn't make sense for you to eat all that cost, because again, it goes to, does that value really would that RAG really bring value, saving people 5 seconds a day rather than going to your KB page of understanding something, right? And there's some people, like some companies don't understand, is I work with some companies, it's like, we want to put all our SharePoint pages and we want to RAG it and we want to make it good, blah, blah, blah. I'm like, okay, well, how much data do you have? Like we have we have over 6 million pages, and each of the 6 million pages have this much data on it, that much data on it. It's like, well, again, it goes back to the clean data. How much of that data is still usable? How much of it's old? Have you cleaned it? Has it this? Has it that? Has it this? And it goes that. And again, not a lot of companies have cleaned it, right? You probably go to your company page and find something that was posted 5 years ago that has been expired or it's not updated yet, right? So sometimes it just doesn't make sense to sort of build when it comes to those types of conversations. So again, it goes back to depends. But you having something smaller, you can use that as well. Okay, so next is total cost of implementation. What we said TCO. So total cost of implementation is what is your initial cost? How much does it cost to create that POC? How much does it cost to look into developing it? What will be your ongoing cost? And again, this is very important when we talk about week 6 and you're developing your project strategy, is how much is the initial cost of testing this, right? We want to make sure it's successful, that your project is successful in AI. What will be the ongoing cost of running this? If you're running a chatbot and you know you have a volume of 20,000 people monthly attending your chatbot, what's that cost going to be? How are you going to be updating and monitoring it? How are you looking at what do you have to have any subscriptions or any recurring cost? And is there any additional training to be happening? Let's say you have a new product coming out. It's great that you did everything on your previous product, but now you have to go and implement your new product and add this to your training data set into your AI chat product that's coming out. Is it scalable? Is there troubleshooting you have to do, etc.? So that's a total cost of ownership. Looking at what is your first initial cost, what's your ongoing cost, and where you're hitting costs from there. And that's something very important. And when you present your AI strategy, please take this into account of how you're going to be doing this and how you're going to be pulling it out through your rollout phase. Okay, so I'll answer your question afterwards. Just stay on topic for that. So before we get into costing and getting into there, we have to help individuals who are sort of not up to speed. What are tokens? So an LLM understands things not in words, but in tokens. They're a piece of text that LLMs treats as single units. So example, they can be parts of words, whole words, or punctuations. For example, English averages 4 characters per token. Model providers charge based on token usage. So example, OpenAI has their own token calculator because it's the way how their transformer model works when understanding a word. Meanwhile, Llama has their own token usage because how they understand and how they treat words is differently the way that OpenAI treats it. So an example of a token would be converting a word into a vector, right? So example, you would say the word here, but an LLM will translate that word to 100100, like sort of a binary code, and that turns into a vector store. And that's what tokens are. That's the conversion of the words in English to machine, for example, it is a machine learning model. It's a neural network built inside these LLMs that need to understand these binary numbers, these vector stores. This is why it's hard for it to understand, like to say that right now these models are super intelligent, because right now what they're doing is they're grabbing everything, putting into a vector store, and looking for relationships between these different numerical values. So they're not actually looking at the word here. They're viewing that word here as a binary vector store, and then from that binary vector store, they're learning what types of relationships it has through inside the transformers, different types of attention mechanisms. So how does it work? The model first breaks down text into tokens using something called a tokenizer. It finds frequently used words and phrases to get their own tokens, and then split words into smaller subword piecings. For example, if he sees the word understanding, it will break it out to understanding, and then convert this into a token and convert standing into a token and put them together. Hello as a single token, and anti-establishmentarianism into multiple tokens, right? So just showing of how tokenization works. So it's not just using one word equal to one token. Each model breaks out into different parts and say, this is 1 token, this is 2 tokens, this is 3 tokens, etc. So cost control. There's input tokens. That means the maximum input you can feed to a model, and output tokens, which is the maximum output a model can do. So it doesn't matter if you feed it a whole Harry Potter book and you're telling it to say, give me a response. It can't then spit you out another whole Harry Potter book because there's a maximum input and a maximum output. It can spit in, and spit out. There's a control in place, so it's going to go over its limit and then fail on you. Here's some rules of token economies. Text input tokens are text sent to the model either through prompts and questions. So let's say you have a prompt at the top that you're saying you need to say this prompt, like this is your system prompt, right? This is the prompt that always will go in with every single time someone writes a message. Not only your message will come in as a token, but your system prompt will come as a token as well. So we'll combine both of those, and those are your input tokens and always will be your input tokens. Your output tokens are text generated by the model. Output tokens usually cost 2 to 4 times more the price of the input tokens. And there's a context window, which is the maximum tokens a model can process at once. Those are so the top rules of understanding how these tokens work. So some practical implications, cost controls. The shorter your prompts, the lower the cost. So the less you write to the LLM, the lower it's going to cost you. The more you write, the more it's going to cost you. Longer responses cost more. Let's say you write very long story about shoes. That's cool. You shorted that prompt. You made it very short. That cost you 2 cents to write. But then because you put very long story and inputted a story of 120,000 characters, that prompt cost you now 18 cents or 20 cents to generate, because it gave a longer output because you prompted it to give a longer response. So again, the longer response costs more, right? And we know that here in the output tokens, it's usually 2 to 4 times the price of an input token. So it costs more to extract that text. Again, I'm strictly talking here about APIs, right? API costs only. So optimization, efficient prompting saves you money. So again, if you have in your prompt, give clear, short, direct responses only. That will also help optimize your costing. So how does this cost work? So let's say you have, like I said before, you write you write certain questions to your model, and it costs $2.50 for the input. The output of that is $10 for 1 million tokens. So that's $12.50. So yeah, sorry, this is for 1 million tokens. I put, for example, here, I did the calculations for you. 1 million tokens monthly for input and output. $2.50 input, $10 for output. ChatGPT will give you $12.50 for 1 million tokens for 1 month. For Claude, it's more expensive for your input at $3, and same for its output. It's $18 a month for Claude, and 3.5, which is a little cheaper than 4.0, was 50 cents in input, and output was $2. But we know that 3.5 is going to be, I think, depreciated very soon. So right now, I think the cheapest model is Gemini Pro. They've come out with huge price drops. But this is just giving an example of if you had running 1 million tokens monthly, what would your average bill cost be just for using API? Nagesh, you had a question for
Yeah, a couple of questions actually. So when you say the input and then output and then 1 million tokens monthly, are you saying 1 million of input and 1 million of output as outcome, or which makes it like 1 plus 1, right? Which is 2 million, but you have to calculate separately, I understand. So.
Yeah. So for this one, I just meant like if you had example, if 1 million tokens were used monthly, right? And let's say 500,000 was for input, 500,000 was for output. Just doing something similar like that. I was just trying to say in the end, 1 million tokens was used like in the model. There's like a straight 500, like 50-50 split.
Okay, got it. Okay, and the second question which I had was now if you're going to use RAG, right? Now the RAG output will actually go as the part of the input, or does it come as the part of I would assume it's going to be part of the input, right? Is that correct?
No, so input would be the question from the user. So example, how do I use this? How do I use this lab, right? So the LM is going to do that's your input. So it's going to go and try to answer it. But you'll route it to your RAG. You'll feed it the top prompts. Now the LLM will then grab the top context and combine it with the output response. So the cost of a RAG is not on the input, but on the output, because you're now generating more output. So what it does is the LLM uses it as like sort of memory, right? Because the whole point of RAG is an LLM doesn't have the information at all. So let's say it's your company data. It doesn't know anything about your company. But when you do a RAG, what happens is you're not using an LLM to extract things from the RAG. You're using embeddings, an embedding model, right? An embedding will say, this person responses are very likely to be very matched to these chunks and this vector store. So we'll grab these top chunks and then feed that to the LLM and put that to the combined response. So now you have the top chunks pushing it to the LLM. The LLM will say, oh, okay, here's the user's prompt. Here's the chunks. Here's how I'll respond. And then we'll use that to respond. So it won't be part of, it's not be part of the input, because the input question is only the, how is this lab being used? But on the output, it's going to read the two together and then try to respond that way.
I see. Yeah, so I mean, maybe I'm not understanding the complete flow on the from the prompt to the LLM. So basically, if somebody asks a prompt, right, then it goes to LLM, and from LLM there would be a callback for giving, hey, give me all the chunks related to this, and then it takes the chunks and then sends it back. How does that flow work?
Let me see if I can find like a good RAG architecture that's, but we might have to, if you stay a couple minutes after class, I can definitely go through the RAG architecture. But we can definitely go into that.
Yeah, I think it's like super important somewhat, like to understand like how that interaction and the arrows go between the LLM and the RAG, I feel. So it might be beneficial for all of us. Is what I feel.
Yeah. Just 1 second. It was freezing for a sec. 1 sec. Okay, let's continue this, and then if you have 10 minutes after class, I can definitely go through it, and we can definitely go through it Wednesday as well. I usually teach this on the GenAI 101 course, so I have a PowerPoint just specifically all on how the RAG architecture works and how it works. But definitely, what you have to understand that is that in order to pull chunks to the model, it's not using an LLM to pull the chunks. It's using what we call a similarity score on your vector embeddings. But we can definitely get into that.
Yeah, I mean, it throws me off a little bit that it is using it as output, which is expensive, right? So if that makes sense. So that's, yeah.
Okay, perfect. Okay, we'll definitely get into that. Okay, any questions on this last page? Let me just double check here. Okay. So I'll go through, probably have time to go through a cost comparison of just using API, and we'll definitely do a RAG breakdown as well. I have a RAG architecture cost breakdown and how to optimize RAG. So that's very good that we're going to talk about this here. But below is a chart comparing monthly chatbot estimates for LLM deployment using OpenAI GPT-4o. Again, this is the latest pricing I found last week on what the latest price is versus Gemini 2.0, which I think is the model's latest model that we have here. And we're going to assume 50 conversations per day. Let's say this is a typical chatbot. We're just receiving 50 conversations per day, which each conversation uses about 200 characters. And for 200 characters is about, I have down here, the quick brown fox jumps over the lazy dog. We see have you seen how fast it can run? It's really remarkable. So again, it's probably about 2 to 3, 4 sentences maximum, right? This is what we're looking for in types of that. So what would this price look like, and what would actually be costing of this? So for Jupyter 4o, as we saw with the last page before, for 1 million input tokens, it's $250. And for 1 million output tokens, it's $10. And the same thing for Gemini. Gemini is $1.25 for 1 million inputs and $5 for output, right? So we know that Gemini 2.0 is a cheaper model. Right now, Google is offering this at a cheaper API rate. So again, same tokens, same characters. What's the totally monthly cost of input, monthly output, and what the totally monthly cost would be, right? So for only using this 50 conversations per day, we times it by how many characters are being done on a monthly usage, times that monthly output cost, it's only coming to $1.24 per month, right? So it's not super expensive. When you're looking at conversations, the very simple of the quick brown jumps over the fox. Again, when we look at that, that's only about 200 characters. So 200 characters for input is very low tokens, right? Very low. So when we multiply those tokens by how much characters we have there. No, some question, why is Gemini 2.0? I think Google just can offer such a big discount because they have the infrastructure. The point of hosting, the point of having the cost of using LLMs is not the LLM itself. It's hosting the LLM and being able to run it on GPUs that are fast enough. So this is why Gemini, I believe, and Google can offer something cheaper than OpenAI, is because they can host it on their own servers. They're hosting it on their own server list. They're hosting it on on a cheaper location. I know GPT-4o has reached out with Microsoft, but since they have joined with Microsoft, they haven't been really dropping that price that much. They're trying to keep it very competitive than that. So is quality and output from Gemini a bit lower than GPT? No, I think that's something you have to decide for yourself. I think Gemini is very competitive to ChatGPT 4o.
So here, the monthly input usage is like way low, isn't it? Like 75,000 tokens or
Yes.
300,000 is just like, probably will, in a half an hour, we could just probably, it depends on the use case, of course, but unless if it goes to production, it's a high, volume site, then I would think that this is, yeah.
For example, this is 50 conversations. So this is where I just did on the right side. If you're able to scale this to 1,000 conversations per day, let's say 20 times more, the monthly cost would be $24.80, and Gemini 12.0, $12.40 a month. Or at 10,000 conversations per day, $240 a month, or $120 a month. So as you can see here, it's not that expensive to run AI or LLMs. The cost is literally 0.0008 cents on Gemini 2.0 for one token. It's the cost of running these things are very low. So this is what going back to what I wrote on the FERT. Klarna was able to show that they were making $400 million of return using these OpenAI. They're using their own AI interfaces in order to automate a lot of these tasks. So the cost of using just text, again, this is only text LLM. This is not including voice, not including images, multimodals, anything like that, than that. So so that's a question. So that's one of the reasons why we definitely want to look into this. So I know Srinivas had a very good question. Why output tokens are more costlier than input tokens? Isn't it usually the case the number of words in the query is way lower than that of the output? And also, if we don't have control on how many words it could spit out, how can I understand how much my question cost? So that's a very good question. So why output tokens are more costly than input tokens? Again, it's the cost of compute. You're paying for cost of compute, not the cost of input. Isn't it usually the case that the number of words in the query is way lower than the than the output? Depends, right? If you prompt the model to say, give me a long story about shoes, your input prompt is very small. It's only it's probably like 4 or 5 tokens. You're prompting it to give you a long story, and now you're giving it a token of, now it's going to output you something that could have 60 or 80 tokens, right? So that's one thing to be careful of. Also, if I don't have control of how many words it could spit out. So that's something where that's something that's a fallacy. And again, this is something where most people don't know that there is a way to maximize how much output it can have. And again, this is something that we go through in 101 is that there are parameters that you can put in. You can see that here's the maximum output tokens I want you to give this way versus a lot more. Yes. And exactly when you write something to an LLM, and as you can see that LLMs are very verbose, and that's something that you might see as well. If you ask it to do a code for you, it spits out. And a lot of problems is that a lot of people are doing a lot of vibe coding and they're using Claude. And going back to Claude, going back to what we had in the previous post, Claude is not very cheap. It's $3 to $18 an output. Someone said they coded with Claude 3.7 using their API Claude cost, and they said they got up to, I think it was $480 within 2 hours of just trying to code back and forth, and Claude was giving very verbose code and things like that as well, right? So this is where you have to be very careful of how much, which model you're using. Is it really worth the cost? There is a model from ChatGPT called O1, which is said to cost about $30,000 for one query. This is one part of the large reasoning models that they have. And that's the one that's supposed to hit all the top mathematical marks that they have. They're going to be releasing that very soon. I think it's only to certain select customers that they're offering this to. But imagine someone trying to prompt something. You have to be very careful, right? And again, you wouldn't want someone very inexperienced to write a prompt to that $30,000 prompt model and try to get it out right. Like you would try to have someone who knows a little bit more about prompt engineering, understanding what the problem and what the outcome is and what you're trying to get most out of it, right? So there's different ways how these APIs work. So let's break down of how to do a monthly cost estimate, because we just talked about this is just strictly, again, cost of just using API. But usually if you're trying to build something with a RAG, there's a lot of different hidden costs that come with this, right? So let's say if you're using a Pinecone serverless, where you're storing your vector store, you have about 10,000 vector stores, 10,000 vectors stored in that. The monthly cost of this is going to be $5 to $10, right? Or $7 to $12. And again, this is only 10,000 vectors, which is 1.5 dimensions. This is what I said before. If you had 1 trillion data points and data things that you want to put in a vector store, you can see this number will inflate a lot, depending on how much data you're trying to store in your RAG. There's different I just put two different types of vector stores below as well, Quadrant and Weaviate, so you can see a little bit of price difference between each one as you go. And of course, there is your data processing cost. In order to put it into a vector store, when you have your text, you need to clean it, chunk it, and embed it before it gets into a vector store, correct? So, and when you grab your chunk, you embed it, and then you put it into a vector store, there's a cost to do that. And if you're looking at 10,000 vectors, this is going to cost you about $10 to $15 in compute cost if you don't have a good discount with your provider. LM API cost, I put in here again, Gemini 4.0, 2.0, 0162, blah, 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 blah. And then let's say you have you're able to build your RAG and it's supposed to pull information out. You definitely want a re-ranker to look into, is it really the best chunks that were really coming out? A re-ranker will look at your top chunks that was getting out before it goes to an LLM and then re-rank them to what should be the top chunk coming out. Then after you have hosted and you created your RAG, you hosted your you need to put this into an endpoint, right? You create your model. It's not only good enough just to run it. If you're running it locally, you're going to have to host it somewhere and have it. So through AWS, GCP, Azure, these are typically the cost of hosting an API to an endpoint. And then monthly monitoring and logging on top of it. Your total monthly cost for running a RAG per month is going to be $45 to $90. And again, this isn't cost of implementation. If you have 2 to 3 engineers working on this, what was the total cost of salary of them working for that 1 month for those 4 6 weeks to build this out, right? For each of them on top of it. And then the cost of licenses. Do they need to have license to certain things? The cost of that as well, right? So all those are total cost of doing it. But if we were to talk about maintenance cost of running it monthly, right? As we talked about before, we have the initial cost and we have maintenance cost. This is an example of what a maintenance cost would look like simply with only 10,000 vectors, a day. So this is something, again, I really wanted you guys to sit down, think about it, and digest as you go through this of what does it really cost to run a RAG in production and maintain it. Just looking at something that only has 300 queries a day or at 10,000 vector storage. And if you have a large business that receives a lot more volume, obviously those costs will go up. Could go up to $300 or $400 a month. Certain places like Databricks, I know, charges at least $300, $400 monthly just even to open up a vector store on their database. And Azure as well, they charge you a monthly fee. It doesn't matter how many vectors you have in there and how many dimensions you have, etc. So these are just tough, rough estimates, but just showing you that when you build this RAG and you really want to put a production, you need to look at what's your component, what's your data processing, where it's going to be stored, what's your API cost, your API, your hosting, and your monitoring. Okay, and then I'm going to pause here because we're just 5 minutes over time, but we'll talk about how to optimize, like before someone talked about caching, going from there, but well, just take a pause from here. We'll stop from here, but I think this is a good introduction, good stuff to think about of when you're running a RAG or running an chatbot, what are the totally monthly costs you need to think about? It's not simply just an LLM being able to answer questions, but you should look at everything in terms of what's the cost of hosting it, what's the cost of the endpoints, what's the cost of having a re-ranker being run on your responses every single day, etc. Or are you having a custom one or even one that's done through API, etc. Okay. So I'll pause here. I'll take some questions for those who want to stay back, but thank you so much for those who are able to join today. Hope you're able to grab some knowledge, a little bit more deeper into the business knowledge of running actual AI implementations in productions. Yeah, we'll see what could happen. But hopefully that you guys are able to understand a little bit more of how it works. I'll stay back about 5-10 minutes if people have questions about RAG, questions about APIs. And again, I just want to say thank you for those who are joining and hope to see you next week.
Thank you, Luis.
Okay, so it looks like I'll answer a question someone said here. What does API server do in RAG? So the API, so when you have your LLM chat, it's all ready to go, you need to find a way that people can interact with it. So you need to host your model on an API in which you can use it to our front end. And on the front end, you connect your API to that so they can have interactions with it. So this is where you have an API server to then have somewhere that they can interact with your model.
When you get a chance, can you go back to the RAG model and then just tell how by arrow diagram, or if you have one, to show how the things interact with each other?
Let me see if I can.
Luis, a quick question on this one, the re-ranking.
Yes.
So is it an like the proactive or re-ranking of the I mean, when you say re-ranking, I thought like it's more around the RAG, like the data that is stored in the vector database, right? The ranking of them, the proactive re-ranking of the RAG, the bits in the RAG or a vector store, or is it the response re-ranking?
For sure, I'll definitely answer that. Let me just, if I can just pull
Sure,
up
sure.
here the RAG, because that's all part of the RAG architecture. But what the re-rank does is it re-ranks the embedding. So let's say you have a similarity score, because how it works is when you ask a question to an LLM, your question gets embedded, right? Your question goes to a vector store embedding. Now, once it becomes embedded, it looks against your vector store and does something called a similarity score. A similarity score is it's one way of doing a search on your RAG. We'll look at which of those vector stores become embedded.
Yeah, I understand that now. Yeah, it's basically the re-ranking of the vectors in the vector store for the RAG, right? Yeah.
So let's say
this re-ranking has to happen every time there is a prompt, is it? It does seem like it. Is it correct?
So re-ranking is an optimization technique to get better responses from your RAG model. So it's not necessary, it's an optimization technique. So example, when you do similarity score on your vector store, it's going to pull you the top ones that are similarity. But re-ranker can be an LLM that then looks at your responses and say, actually, you know what? Just because this one says cheese and bread, does it actually mean it's actually, although it's a similar context, this person's talking about, I don't know, like Finland or something like that. So then it goes into the top chunks that I was able to extract and say, actually, response number 8 should be number 1. And then the re-ranker will then move response number 8 that your similarity score did to the top and then send that to your RAG instead.
Okay, so but then you're saying that there is a cohere re-rank, right? So that is the cohere re-rank is a solution, and then it does look like you can basically integrate your in the flow of RAG plus LLM. So it would be interesting to see where exactly it would how would you call it, and then how would you integrate? I think it's more in line with what Satya had in his question too.
Let's see here, architecture and RAG.
Yeah, I understand that now. So one probably additional thing to the same thing, Luis, actually, how does the cohere or re-ranking algorithm knows what is the better rank for a certain chunk kind of a thing? Because there is no user interaction. Like, for example, okay, the places where the user interaction is there, like, for example, in the case of chat agent, like you say, okay, fine, do you like this output or something like that, right? And like, so user is giving an input saying that, yes, this is more relevant response to me. So that, like it can help in the re-ranking kind of a thing. But when there is no such, back and forth, like generative AI, the chat agents kind of a thing, how does the re-ranker work in that case?
So I said before, like similarity. So before, how it works is you use example. There's different ways of doing it, right? There's something called hybrid, where you can use similarity score or you can use approximate near neighbors. There's different ways to pull in what is the most and which embeddings are the one that are most similar to the question being asked to be asked, right? Because you're trying to do that as fast as possible. Once you're able to extract from those, it doesn't matter, it's either through a hybrid search or through a normal, simpler similarity search, you can then extract information from that. And then once you have the top chunks, you can then have a re-ranker, which is one done through LLM, which will say, it will look at the context saying, this person is asking for this question. And they'll look at your embedding rank, look at your one that's been extracted from the embeddings and say, actually, let's reshuffle them to be this one to be the top one to the top. And the reason why is because when your similarity search happens, it could be that example, like in order to understand this a little bit more, you have to understand that how embeddings and rules are created, right? Embeddings are created to understand how words and context matter and have relationships with one another. Similar as shoe has to do with foot, as jacket has to do with this. So when these embeddings are happening, there are rules and relationships trying to match with rules and relationship, but sometimes it doesn't make sense. It could be saying, does this thing have cancer? And in the star saying like this cancer is a Sagittarius. It's a star, really. It's a constellation. So your RAG's pulling up Cancer because similarity score shows that Cancer. This person have Cancer. In your RAG, you have Cancer as a star, but because it says the word Cancer, it has more relationship, has more importance. So therefore, the star will show up as number 1 in your embedding model. So how would a re-ranker would look like is that if using Cohere's API, for example, it will look at all your embeddings and show that, let's say you have star, 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 and the number 7 is actually talking about a health condition called cancer. Cohere's ranker will use LLM to analyze your embeddings and it's a very small LLM that will look at it and try to understand through context of the user's question, which of these contexts actually match the user's question rather than based off similarity score. And then it will retrieve that last one that's actually talking about someone's health and push it to the top. And that's sort of the difference between most people have issues right now in RAGs is that they have similar words with attentions that aren't being dragged to the top. And this is because they're not looking at the chunks have been optimized. They're not using re-rankers. They're not using these things to really get the best response from them. So hopefully that really explains a little bit more of how the re-ranker helps pulls the information out that way. And they do more of a semantic, rather than just doing similarity. They also
If we don't have a cohere re-rank, then LLM by itself does the re-ranking or it doesn't?
No, it will just use the top ones that you're feeding it to. So you can choose the top, give it the top three, you can give it the top three chunks, or you say use the top one chunk, and when you do your RAG, you have to specify which of the chunks are you having it to read from that's going to pull from it.
Okay, so the action of pulling the relevant information, yeah, probably if we look into the diagram again, I can specifically point and then talk about that maybe. It doesn't have to be today if you're having if we don't have a relevant diagram handy. It can happen Wednesday also, but.
Well, I think this is gonna, let's see here. I'm trying to find one. Okay, let's try this one. So there's different types of RAGs, right? You have your basic RAG, which will then have a user query. We'll go to your documents, index your documents, right, from your vector store. Retrieve which documents are the most related through vector store. And then it gets to your frozen LLM and then outputs your data, right? And a typical RAG, that's how it works on that type of side.
Can I ask a question before you go to the advanced one? So the retrieval happens by the library, which integrates with the vector store, right? Is that correct in this case? And it tries to pull in from the vector store based on the embedded matching and then getting the relevant information. And is that correct?
Correct. So how it works, when you do RAG, you need to, whatever document you're using needs to be embedded. So you'll see one line of your text, and then you'll see one line of your embeddings. So I think I have an example of there's different embedding models. I have something in here with this. Yeah, so your documents need to be converted into chunks and vector stores, right? And then once they're embedded into chunks, they become embeddings. So when you ask a question, your question also becomes an embedding, right? So then what happens is that when you look and you're trying to say, okay, which embeddings matches the most to this user's question, it's going to pull you certain chunks that are the most related to it. Because the reason why is because LLMs have that context window fail, right? It can only understand up to 130,000 context max. So the reason why you're doing RAG in the first place is because you have tons of documents. You have 50 PDFs that you only want to grab the most relevant information from, and you want to make sure you can read all your library data. So you don't want to feed it, you don't want it to have and read everything because you know that the cost of processing that and the output is going to be really expensive as you're trying to read all the information in and trying to answer it. So what you're trying to do here is trying to pull out the most relevant chunks from your vector store and then feed that to the LLM to combine the text and the prompt and to answer with the RAG.
So let's say we are using Gemini or OpenAI based library. So that library takes in just the RAG information, and then that library takes care of the embedding matching. Is that correct? Like I don't remember exactly how that library basically works.
So to do, for example, you don't have to write a library about changing the user's question into its embedding. It's going to happen automatically. You don't have to worry about that. But the pre-processing, grabbing your documents, embedding your documents, and putting to a vector store is something that you'll have to do manually. Like it's something that there's no automation, there's no library for it. This is a specific code that you'll have to write that grabs your chunks, embeds it, and puts them to a vector store. Once your vector store is ready that has the chunks, the vector store beside them, when you have a question, it's going to go and use a retrieval method, usually through a similarity score, and then compare which of all these chunks have the highest similarity score from one another.
Okay, I think yeah. So now I'm assuming that once you get the relevant documents, there is a re-ranking aspect of it, even before it goes to the LLM, correct?
No. So on a typical RAG, there isn't a re-ranker. This is where you would have to then implement an advanced RAG where you can do different types of techniques, right? And you can do, for example, there's in a typical RAG, like we said before, this is just basic RAG. But once you get into something called advanced RAGs, there's multiple techniques you can do to improve basic RAGs, like I said before. Query routing, is the response actually is the actual response actually relevant? Yes or no? Query rewriting, you can fix misspelled words, fix spelling mistakes, makes things more relevant to pull things from your context. And you can do something called query expansion and expand the user's questions multiple times before it gets to the retrieval phase. Once you go into the retrieval phase, then you can have something that's more accurate, spelled correctly, and be able to match more better with your retrieval embeddings. Then once you have your top retrieval embeddings, you can then do a re-rank that re-ranks the embeddings to be better and to be the top position to be better. Like I said before, you can do a summary of, you can create an LLM that summarizes all the chunks and it just gives that and feed that to the LLM, or you can do a fusion of all the different, put all the 3 chunks together and just throw it all to the LLM. And then you give it to the LLM, then you come with the output. So there's different ways of doing it. And you can see before to the right, there's different ways of retrieve. You can also even have a check here. Is it, you can even have a grounding. Is the response make sense? Is the response ground enough? It's not. Go back and retrieve and do the same steps again. And retrieve and do the same steps again until you have something that's grounded, right? So there's different ways to do multiple types of RAGs. There's different ways to do it, and there's different techniques as well. But
Sorry, so for the query routing and then rewriting, that's a separate solution which we'll have to have, or a library which we have to use. And then for the re-rank also looks like you will have to use something like a Cohere library to use that in a solution for that, right? Which is a mini LLM is what you said, right?
So these are like some of the pre-retrieval is an LLM as well, right? You can prompt an LLM to do the query rewriting for you, prompt an LLM to do query expansions, and you can prompt an LLM to do re-ranking, prompt an LLM to do summary for you, prompt an LLM to do fusions. So you would have probably one call, but you would have multiple, maybe 5 or 6 different LLM calls happening before you do an output, right?
Oh, it
So-
would be separate prompts for that, or would it be one prompt which will ask you to do all these things? How does it work?
You would have a separate tool. It would probably be like LLM summary tool, and you would say your job is to summarize everything that comes in here, and then you would train that. You would use that and make that into a function, and then when you're in a retrieval phase, you would call that function to summarize the chunks, right? But it still counts as an LLM call. You're still counting an LLM to function to call that summary.
Okay,
Same
so
thing.
are we going to look at the code to do all these things sometime, or
So that's yeah. So we did that in we did a little bit on the Gemini 101. We did the code of doing the whole
right?
RAG, things like that. But 103 will be going through more the advanced techniques of how to add in the re-rank, how to add in the rerouting, query expansion, etc. from there.
Got it. Okay, thank you. Thanks for explaining.
All right, no worries. All right, I think I gotta go. Time's up. But if you have more questions, we'll meet everyone on Wednesday. And please bring your questions. If you have questions beforehand, so I can prepare with maybe another diagram if you like, I can be able to explain it better.
Yeah, thank you so much. Yeah, bye.
All right, thanks everyone. Okay, later. Bye.
Thank you.